students. I decided to record this a little bit different than my previous videos. I hope you like it and that you learn a lot from it. So we're going to start section 7.3. We're on page 410 in your textbook. So why don't you get that out and follow along as I start teaching. So here we go. Okay, so we're on page 410 here. And we're going to talk about rational exponents. This is section 7.3. So go ahead and follow along and take some notes and work with me as I am writing down some examples. So rational exponents. So let's first discuss how are they different than regular exponents. Well, a rational exponent is a fractional exponent. Okay, so here's some examples. So like b to the 1/3 power, or x to the 3/4, or 3 to the 1/2. So these all have fractions, and we're going to interpret what do these mean and how do I solve some of these problems, okay? So we're going to look at the gray box called the key concept. So let's define what b to the 1/n power means. So that's going to equal, and we're actually going to use a root. So the n is going to be what's called the index of the root. And then you can write it like this, where the exponent goes inside, or you can write it like this, where the index is still n, and then you can put parentheses around it, and it'll be to the 1st power. But we're mainly going to look at this one today and play around with it and solve some problems. So this is called the index of your root. This right here is called the radicand of the root, okay? And then the 1 is going to be the exponent here. And again, the exponent can go to inside or it can go outside. Okay, so let's look at number 1. We're just going to convert from rational form to exponential form. So you can put that down for your heading here. We're going to go from rational form to, we're actually going to go from exponential to rational form is what we want here. So, or radical form. So we're going to go from exponential form to radical. And then we'll go the other direction later on in this lesson. So, okay, so first we're going to start off with a base here, 25, and it's raised to the 1/2 power, okay? So that means it's just the square root of 25. Well, that means, okay, this means right here, what number times itself so that goes back to 25 is what's called a square number. So the answer to that question is going to be 5. Because 5 times 5 gives us 25. And there are 2 5s. Now, in mathematics, we don't usually write a 2 here. You can write it here to remind yourself that it's a 2, but it's usually implied. Okay, so the 2 means the number of multiplications. Here we have 2 numbers multiplied together. So 2 numbers multiplied. Okay, so the index always is going to tell you how many numbers you have multiplied together by itself. Okay, let's go on to another one here. I'm going to start a new board. So, okay. So let's look at 8 to the 1/3 power. So that means we want the cube root of 8. Okay, so let's think about it. What number times itself 3 times? So we have to have 3 multiplications here. And it has to equal 8, and all the numbers have to be the same. So the only way that can happen is if you take 2 times 2, and then you have 1 more 2. So the cube root of 8 is the number 2, because there's 3 multiplications of 2. Okay, 3 means 3 numbers multiplied together. Well, that only happens with the number 2. Okay, so let's look at another one here. So that was number 2. Now we're going to move on to number 3 here. So let's say that I have something like this. 5x to the 1/2 power. Okay, so let's look at this number here. This really means 5 times x to the 1/2. So the 1/2 is only being applied to the x term. This is really an implied 1, so it's only to the x term and not the 5, because the 5 has its own exponent of 1. So let's go ahead and change that into radical form. So it's going to be 5. You're going to have your root here, and then it's going to be x. That's the answer to that one. Let's try another one. So let's say I have 3y to the 1/3 power. So again, the 1/3 is only applied to the y term. So if I were to write that in radical form, you're going to have 3 times the cube root of y. So that's what that looks like. Now let's go on to the other part of this example, another similar scenario that you could have. So let's say I have the quantity 5x to the 1/2 power. So that's a little bit different, isn't it? So that means we're gonna apply the power property here. And we're gonna apply this 1/2 to each of our terms. So that means it's gonna be 5 to the 1/2 times x to the 1/2. So that means I'm gonna have the square root of 5 times the square root of x. Well, both of the indexes match. So I can combine them and write it as 1 square root. So your final answer will look like this. 5x, and then we're going to take the square root of that, and that's the answer. Okay, let's try another one. Number 6. So let's say I have something similar to number 4. I have 3y to the 1/3 power. So that means my index is 3, and I'm going to put both terms underneath the radical, and I'm finished. Okay, so let's move on to the next part of our lesson here and look at, okay, well, what happens if I have a different index here? Okay, so something other than 3 and 2. So let's say that I have something like this. We're going to go now from radical form to exponential form. So that's our next section. Okay, radical form to exponential form. All right, so let's start off with this example here. So let's say I have the cube root of 27. Okay, so that means I'm going to have 27 to the 1/3 power. Well, let's see if I can't simplify this down a little bit. I know 27 is 3 cubed, but I still have that 1/3 power here. So I can cancel these. And my answer is going to be the number 3. Well, let's check ourselves here. Is 3 times 3 times 3 equal to 27? So this is going to be 9 times 3, and it is 27. So this matches my Radicand here, and I know it's correct. And so the answer is indeed 3. Okay, so let's look at another one, number 2 here. Let's say I have the 5th root of 32. So that's going to be 32 to the 1/5 power. Okay, so you're like, well, Miss Poust, I know that 4 times 8 is 32. We have to put parentheses around it because this is a product here. So that's why you need the parentheses. Well, I know that 2 times 2 is 4. And I also know that 2 times 2 times 2 is 8. And it's all to the 1/5 power. Well, how many 2's do you have here? Well, there's 5. So I can rewrite it as 2 to the 5th times 1/5. Well, my 5's are going to cancel. And so I come down to an answer of just 2. Okay, so let's go to a new board and try some other ones, just so you get the hang of it. So let's try the cube root of 64. So 64, this would turn out to be 64 to the 1/3 power if I were to convert it. Well, I know 64 is 8 times 8. And again, you need parentheses and you have to put the 1/3 up here. Well, 8 is really 3 2's. And then we have another 3 2's here. So how many 2's do we have? Well, we have 6. So this is going to be 2 to the 6th power times 1/3. So these are going to cancel. And so my answer is going to be 2 squared, which is really the number 4. Okay, now there's another way that you can check your answer. So let's go ahead and check it. So that's going to be 4 times 4 times 4. So that's going to be 16 times 4, which is indeed 64. And we did it right because there's 3 4's and the 64 matches the radicand underneath. So let's try one more here. Let's go to a new board. Okay, so let's say I have the 4th root of 10,000. Okay. So let's switch that to 10,000 to the 4th power, to the 1/4 power. So that's what it looks like in exponential form. Well, if I count the zeros, this is really 10 to the 4th power, and then it's times 1/4. And these are going to cancel, and you're left with 10 to the 1st, which is 10. All right, we're going to move on to the next example here. Well, what if our fraction, what if this changes right here? What if my numerator changes to something other than 1? So let's talk about that. So the next part is when we have b to the m over n power. Okay, so it's sort of similar. So that means I'm going to have b under the radical. N is still going to be my index, and m is the exponent. And remember, the exponent can go inside, or you can move it to the outside. Okay. Sometimes it's more advantageous to have the exponent inside. Sometimes it's more advantageous to have it outside. So you can choose either way to write it. So let's look at how we write some of these problems and how we solve some of them. So, all right, number 1. So let's say we have 64 to the 2/3 power. So that means I'm going to have the cube root of 64, and I'm going to write it with the exponent on the outside here. So the 2 is going to go here. Well, we just did this problem. I know what the cube root of 64 is. The cube root of 64 is 4. So that's going to be 4 squared, which is 16. Okay, so another way you could think about it, if we want to switch this, so there's another way you could think about this problem too. 64 to the 2/3. So let's just leave it in exponential form. So I know that 64 is 4 to the 3rd times 2 over 3. So these cancel, and I'm left with 4 squared, which is 16. So there's 2 different ways you could approach this problem. You could write it in radical form and solve it, or just leave it in exponential form, rewrite the base, and see if you can't cancel some numbers here. Okay, so let's look at another one here, number 2. Let's say I have 36 to the 3/2 power. Okay, so let's say the directions were to use radicals to solve. Okay, use radicals. Solve. So you have to really read the directions today on your homework, okay? So if I use radicals, I'm going to have to change this into radical form. So that's going to be the square root, of 36, and I'm going to cube it. Well, we know the square root of 36 is 6, and then 6 cubed is all I have to figure out, and that's going to come out to be 216. So here we used radicals. We changed it to radical form first. Okay, so let's say the directions were, let's do another set of directions that say use exponents to solve. So we're going to write that a little bit different. Let's see if I can fit it here. Okay, so that means I'm going to start off writing it as 6 squared, and then it's going to be times 3 over 2. So now I can cancel these. I get 6 to the third, and then I just work it out, and it's 216. So again, really watch the directions, make sure that you're going to use the right form. Okay, so let's look at 2 more examples, and then we'll be ready to start on your homework assignment. So, all right, my next example, so this is number 4, is going to be 27 to the 2/3 power. So let's say that they don't give us any directions. If they don't give you any directions, you can solve it any way you want. So this first one, I'm going to convert 27 as 3 cubed because we just looked at that in a previous example. So I'm going to multiply that times 2/3. The 3's cancel. So I'm left with 3 squared, which is 9. All right, last example here. Let's look at this one here. Let's say we have 256 to the 5/4 power. You're like, well, Miss Poos, 256, that's like a huge number. Well, I know that 256 is really 16 squared. And I'm going to have 5 over 4 here. So this is going to cancel. This is a 1, this is a 2. So it's going to be 16 to the 5/2 power. Well, I also know that 16 is 4 squared times 5/2. So these are going to cancel, and these are going to cancel, and you're left with 4 to the 5th. So then you just get out your handy dandy little calculator and type that in. It's going to be 1,020. So this should cover the first section in section 7.3. That concludes our first part. Come again later on and I will do the second part. Have a great day.